Okay, thank you, Matteo. Hello, everyone. So my aim now is just to explain the title. Okay, this is what I would like to do. Not too many details. I just downloaded the paper, by the way, so I can say if you're interested in detail, you can read them in the paper. Ask Marianna as well. Marianna is eager. Download it, just the Springer. No, it works. And so just one slide about conditional logic. So we have seen something already. Conditional logics are just, so actually are many logics, are many systems that, the aim is to provide an account of conditional, which is different from material implication. We know material implication is not suited for many reasons. And so the conditional logics that we consider are are model-like logics with this kind of binary model operators, the box and the diamond. The box represent more or less the would operator, and the diamond the might operator. These kind of logics are usually defined as extensions of classical logic. So we have classical logic as a base, and then we add principles for the two kind of implications. This kind of logic has many applications and many interpretations, like counterfactual, conditional obligations, preference, and so on. We are not relying on any specific interpretation in this work. There are also many different semantics, non-equivalent semantics, and this is just a picture to say they are many. Okay, this is many more actually than that. What we consider here as a conditional logic is the so-called basic conditional logic that was defined by Cellas in 1975, and these logics provide a kind of foundation of conditional logic by giving a few fundamental principles that are shared by most of them. And the logic is actually very simple. So we have, so in conditionals have two positions, right? The left and the right. In the left here, we only have congruence, which means whenever two sentences are equivalent, then having one that implies psi and the other one that implies same formula psi is also equivalent. And on the right, instead, we have a kind of normality behavior. Right? If you forget about the left component, you will recognize the axioms of modal logic K. Right? This works kind of as a smallest normal conditional logic, and the aim is then to extend it with further principles. Right? This was about classical basic conditional logic. Then why studying intuitionistic conditional logic? Well, actually, if you think, as I do, that intuitionistic logic is a valid form of reasoning, then we are also interested in understanding which kind of, what can we reason about? So what kind of concepts can the logic support? And also a natural question, like we ask in intuitionistic modal logic, is which classical logic do have an intuitionistic counterpart? Now, as I said, we want to study the basic intuitionistic conditional logic, so just let's put the two adjectives together. This is a logic that was proposed by Weiss in, so the literature is quite recent, actually. This was proposed by Weiss in 2019, and it is defined as an intuitionistic variant of Cellas' CK logic in the language with only the would operator. Okay, the might is not present. And it was defined axiomatically by taking IPL, so intuitionistic logic, plus the axioms for the would modality of conditional K. There is a semantic, so we are not getting into semantics in this talk. And so now in this paper, so we call it this way, const CK would, and this should become clear later, hopefully. Then the logic was, so the analysis was continued by Ciardelli and Liu, where they proposed an alternative semantics for the very same logic, and also some extensions, or with, again, with an axiomatic presentation of the logics. And then we also found this very recent paper, but we found it after we wrote our paper, so we don't have much to say about this. Now, already, so the literature is quite small, but it's already sufficiently confused. So our aim was to make some order, actually, before then getting deeper into the topic. We can, so the two problems are nicely presented in the paper by Weiss. So, the first one is if you consider Solnegger's logic C2, which is a logic stronger than CK, and as this axiom, so conditional excluded middle as the characteristic axiom, then we can see that if we take that axiom and also take a very natural and very common conditional logic principle called conditional modus ponens, which is the condition that the wood implies the material implication, then we immediately get the excluded middle principle. And so Weiss' claim is that intuitionistic variant of this kind of logic is not possible because of this reason. Other problem is instead, what about adding also the might operator? And this is kind of similar what you have in intuitionistic modal logic. So the might operator is not defined anymore in terms of the wood operator. And so the question is which principles for the might operator you should keep. So how do we characterize the might operator? And this question was left open by Weiss. Concerning the first problem, so Ciardelli and Liu observed that if you take another formulation of the conditional excluded middle axiom, which is classically equivalent to the previous one, then you can actually define an intuitionistic variant, because with an intuitionistic base, the two axioms are not equivalent, and you can take this one and still be intuitionistic. Concerning instead the addition of the might operator, then there is a proposal, a logic proposed by Alhovikov, which is called intuitionistic CK, INT-CK, that has both Box and Diamond for the modal, for intuitionistic modal logic expert among you. So the semantic is very close to, so it is a Fisher service style semantics, like the one that you have in intuitionistic modal logic. But the point is, as you have in intuitionistic K versus big I versus small I, right? This is the intuitionistic modal logic with both Box and Diamond. Here you have the box. The box fragment of this one is not the same as the logic with only box, right? And you have the same with the wood and might principles here. So now our idea, just to understand a bit more the situation, is to look at this kind of topic using proof theory, right? And the reason is that first of all, we can make some order, right? We have already 3 different systems, and we want to understand better the relations among them. And we also want to define an extension with the diamond of const K wood, which is conservative over this one. And as a byproduct of the analysis, we can also suggest an alternative variant of the logic with the conditional excluded middle, different from the one proposed by Ciardelli and Liu. So what I would like to do is just to explain, to justify the approach. Okay, we will not see many details. So why proof theory instead of just looking at axioms, like it was done until now, essentially? And the reason is that we have already seen an example of axioms that are classically equivalent, but not intuitionistically equivalent. So it is, from an axiomatic point of view, is not clear which axiom we should select among the many possible ones. And also, what about the wood operator? So there is, from an axiomatic point of view, there is no much chance to make it clear. And so I have this picture just to say, this is Marianna and this is me, just to say, we are lost in the intuitionistic conditional jungle. So among the many possible systems that we can define and study, there is no way to orient ourselves in this way. Another possible approach is semantics. Right? Why not semantics then? We can do something better with semantics, so we have a way to follow, which is the heredity property, which is a crucial condition in intuitionistic cryptic models and in all model extensions of it. But we have already seen, so Alhovikov's proposal as a semantics, which has the heredity property, but the extensions is not, so the logic is not conservative over the base logic. So force problem possibly. And also we know for considering intuitionistic counterpart of modal logic K, there are actually many ways of satisfying this property that give rise to different logic. So I counted 7 of them, but maybe there are more. And now so it is still easy to get. Okay, something better, but not entirely satisfying. And what I would like to propose is a kind of instrument like what I call proof-theoretic compass. Right? We can follow a direction in this way, which is the multi versus single succeeding relation. That is a quite common relation in proof theory, in classical versus intuitionistic calculi. This is a relation that for the, as we know, for the propositional logic is known since the very beginning of proof theory, and it has already been applied to define intuitionistic modal logics. Right? And our aim in this way is to understand better the relation between the classical CK and the intuitionistic counterparts, as well as possibly define further intuitionistic counterparts of it, and also extensions. We will look very briefly at extensions. Concerning in CK, so Alhovikov's logic, we can use the material which is already available in the literature, and then to adjust it in such a way that then we get a calculus for that logic. Well, the starting point is the nested calculus for logic K, and there are very beautiful calculi, one for intuitionistic K, which has a kind of, so the polarity mechanism to make it single succeeding somehow. And there is also another calculus instead for classical CK, which has nesting with two positions to represent the two positions of the conditional sentences. If you put them together somehow, then we can get a calculus for intuitionistic CK. And indeed, as I said, we inherit from the intuitionistic calculus the treatment of the intuitionistic base. And from the conditional calculus, this indexing of nested components. This is how the conditional rules look like, right? We have two positions here in the nesting. If you forget about the first position, you will recognize the calculus for IK. That's all I'm going to say. This calculus is sound and complete for the logic, and also Marianna was able to prove cut elimination. I will not say anything about it. Okay, so this kind of single succeeding restriction somehow works for the intuitionistic CK. What about, then let's come back to Weiss logic, so the one with all the Wood operator. We can do actually a very similar procedure, starting instead from a sequent calculus. So the sequent calculus for CK, which was proposed by Pattinson and Schroeder. The very basic observation is that if we restrict it to single succeedent, we get a calculus for Weiss logic, right? This is quite simple. This is just a remark. Okay, so now let's add the diamond, the Wood operator. Okay, so we need, first of all, so the sequent calculus by Pattinson and Schroeder has only the Wood, the Wood operator. This is quite reasonably classical. The diamond is defined in terms of the box. We first of all need to integrate the diamond into the calculus. And once we have the calculus for both of them, we make the single succeeding restriction. And here, in this way, we get a calculus that we call S cos CK. And out of the calculus, then we define the logic. These are the rules. Again, if you forget the formula on the left, this is very close to a calculus for, this is close to the calculus for constructive modal logics, right? Exactly, maybe this is where I say, this is why we call the, this is why we call the logics in this way. So there is a very basic embedding of intuitionistic conditional logics, so the different intuitionistic conditional logics that we have in the literature, to this kind of conditional logics. And we know that IK, so the modal logic with only box, corresponds to this const CK. So now I'm in favor to change the name of this one. It is too late, but we know this is the box fragment of the constructive logics, not of the intuitionistic logic. So we call it constructive. Then from IK to Alhovikov's logic in CK, and this is Vizekera's constructive logic that corresponds to our constructive CK. And these are instead the properties of the calculus and the axiomatization of the corresponding logic. Again, the logic is defined taking intuitionistic logic, congruence rules, and these axioms for box and diamond, so for Wood and might, which are very close to Vizekera's axioms for WK. And in this, so we have a semantics for this logic in the paper, not here, but if you're interested in details, you can find the paper. And this logic instead is conservative over Weiss logic, because if we only consider formulas, so we get rid of formulas with the might, then we have essentially the same derivable principles, right? Now, so we have somehow clarified the very base logic, and then the aim now is to study extensions of it, right? Extensions of it are given by means of conditional axioms. There are a few very standard conditional axioms: the principle of identity, the conditional modus ponens, and the conditional excluded middle that we have seen in previous slides. And we consider these ones, well, there is a very simple reason, which is that they have a very nice sequent calculi. So we can build on this calculi. And the procedure is again the same. So now we consider sequent calculi for CK extended with these axioms. We add the might operator. We get the corresponding calculus. We restrict it to single succedent, and we obtain a corresponding logic. Right? Okay, these are the rules that we get from this procedure, and that will define our calculus. In some rules are just to be added to the basic calculus. Other rules will need instead to change the rules for the diamond and the box operators. But let's just keep it. We can define corresponding axiomatic systems. We get semantics for most of them. The only open problem is the conditional excluded middle diamond axiom here. And we see that actually what we propose is a logic corresponding to here, corresponding to the logics with the conditional excluded middle, that has no characteristic would axiom, but instead has a might axiom, which is this one. There's a difference from Ciardelli and Liu's proposal. Here we say we can define a nice looking logic corresponding to classical logics with conditional excluded middle that has a characteristic might axiom. And if we get rid of the might, we get again logics that were already defined by Weiss. Logics are already there. Okay. It was quick, but it was enough. Okay, let's hop here to our trip through the jungle. So we arrive using the proof-theoretic compass at this point. So we have a clear, what we consider a clear proof-theoretic presentation of the relations between CK and the intuitionistic counterparts, and we also have an extension which is conservative over Weiss logic. We can start studying some extensions, and also we have a semantical characterization of most of them. But what I want to say is that it is true that we have a compass, we can follow somehow direction, but this is not the same as having a GPS track already well prepared. So there are many details to be checked, many choices to be made. For instance, the first thing that we would like to do is consider, well, actually, conditional logic have few of them have sequent calculi, very well looking sequent calculi. There are also TABLEAUX for logics with the cautious monotonicity, and this is the first thing that we'd like to look into. And then it will become more complex, probably. Then also, so far I said, yes, single succedent restriction, I didn't really define what it is. Actually, there are many ways to make a calculus single succedent, and we already know that in the modal logic case, you get from the same calculus by different single succedent restriction, different intuitionistic logic, and the same you can have here. And then I didn't say anything about extensions of the nested calculus instead. So I want to make just a very brief remark about possible extensions of nested calculus, and that I presented as a possible fork that we have in front of us during our exploration of the jungle. Here we have Alendo, Olivetti, and Pozzato with 2Z, sorry, rule characterizing the conditional excluded middle, right? So very basic observation is that if we consider a single succedent restriction like the one that we have considered so far, we get again that our diamond axiom is derivable, but instead Chardell and Lewis axiom is not. If instead we consider another way to make the same calculus intuitionistic with a multi-succeedent approach, we get that both of them are instead derivable. So the very basic observation is that different ways to make something intuitionistic give rise to different intuitionistic counterpart of the logic. And then the questions are, once we get such a counterpart, first of all, very basic question to say it is proof theoretically decent is that whether cut is admissible, right? But then we also, what about possible semantics? Right? There are many semantics, many intuitionistic model semantics. Is there any of them, or we need a new one that applies to this kind of extensions? And how do they relate to their classical counterparts? So this is just a very basic example to say that the exploration of the intuitionistic conditional jungle is only just beginning. And thank you.